Oh, greetings, and welcome to Eureka Math Squared. This is grade 6, Module 4, Lesson 16, Equivalent Algebraic Expressions. All right, so basically we're using everything we can, like the distributive property, using like terms, combining like terms, commutative property, all kinds of fun things. So it's actually a lot of fun. So here we go, page 197. We'll hang out there, but this might be a long video. I think we'll do a lot. All right, so taking a look at this guy here, they want me to distribute and combine like terms to create an equivalent expression. All right, so the first thing I notice here is I have this guy, two terms inside of parenthesis here with a little multiplication guy here outside, which means I can distribute. So that's where I'm headed. I'm going to start with a little distributive property area over here. So I'm just going to hang on to that 2k plus, and I'll deal with this guy here. So here I have a little 3 times 4k, right? So let me just write it all out so you can see it. A little 3 times 4k plus, see that little plus right there? Then I'm going to distribute the 3 to the 5 using multiplication. And that becomes 3 times 5, like that. Okay, so now the next step is to actually just multiply everything I can. So that 2k, I'm just going to leave that hanging out there. Plus, and I can combine these, right? So 3 times 4 times k. So that's really what it means. Look, say 3 times 4 times k gives me a little 12k. And then I've got this guy here. So 3 times 5 equals 15, right? Now I have like terms, right? So I have 2k's, add another 12k's, and you wind up with 14k's. And then I add that 15. And there I go, right? So that's as much as I can do here because I don't know the value of k. So I have 14k's plus another 15, and I am done. All right, so like I said, these are a lot of fun. So let's see, more distributive properties. So I have this 2/3. I'll turn that into multiplication times the 9x, right? And then I'll distribute using multiplication plus, see that plus right there, 2/3, right? That should be a 3, sorry, times the 4, right? So I'm distributing the 2/3. There you go. Distributing the 2/3 to the 4. There you go. And don't forget this guy. So minus 1/3, right? Take him with you. He's along for the ride. Okay, so now I can actually multiply. So let me get rid of this little thing there. Put this over 1 so I can multiply these guys, right? So I can simplify something with the top with something with the bottom. I can divide the 3 by 3 and the 9 by 3, and I get a 3 right there. Right, so 3 divided by 3 is 1. 9 divided by 3 is 3. And I wind up with a 6, right, because 2 times 3 gives me 6, over 1 times 1, which is 1. Don't forget the x. There he is. Now let's deal with these guys. So once again, multiplying fractions, make sure everything's a fraction. So I'll stick that 4 over 1. And I can't simplify, so I can just do 2 times, plus, right? Don't forget the plus. 2 times 4 gives me 8. 3 times 1 gives me 3. So that stays like that. And minus to 1/3. Okay. So now I can combine these guys, right? They can combine. So I can take 1/3 away from 8/3. I wind up with 7/3. Right, should be a 7. Plus, right there was that plus. And then that's 6x like that. Okay, well, I don't want to leave this as improper, so I'm going to go 6x. And this guy becomes 3 goes into plus, 3 goes into 7 twice for 6, right, with 1 left. So 6x plus 2 and 1/3. Okay, so pretty cool. I mean, it takes a little while, but distributive property is neat. So let's cruise on down. I know I have some other things checked off over here. Okay, just gonna cruise on down. There we go. How about page 199? This looked like a fun one. So let's see. So we have Tara, and she buys 8 bags of fruit. Okay, now in each bag, right? Each bag, we're going to write some expressions here. We have R amount of oranges and A amount of apples. So let's use parentheses to symbolize that. So we have oranges and apples in a bag. So the parentheses, let's just simulate that and say, hey, everything in here is that bag. This is my bag. I have some amount of oranges, some amount of apples, except I'm buying 8 of these things. So I'm going to put an 8 on the outside to show that it's multiplication. So 8 sets of R plus A, right? So that's why the R plus A are together, because they're going in the same bag. Let me erase that. Now she also buys 10 peaches. So aside from purchasing all of this stuff, right, she actually buys 10 pieces as well. So I'm just going to add the 10. There it is, see? So write an expression to represent the total number of pieces of actual fruit. Well, I kind of did already, but I can rewrite these. Right, let's distribute. 8 times r, right, so 8 times the r, plus, right, see the plus? The 8 times the a, distributive property, plus the 10. And now I can just combine everything. So I have an 8r plus 8a plus 10. There you go. All right, so either one is acceptable. You want to use this one, you want to use that original one. They're equivalent to one another, right? See, equals. They're equivalent, so it's no big deal. You can use any one you want. But now we put it into practice because they said, hey, we have 8 oranges and 6 apples. All right, so how many total? Now I can find out how many total fruit. Let me try this one first. First thing I always do is write down the actual expression. There you go. You know what? We'll do the other one as well, this guy over here. So over here, we'll do the 8r plus 8a plus a 10. And we'll run the two of them simultaneously, okay? So we have 8 oranges. Oranges is the r, that's this guy. And we have 6 apples, that's this guy. So I'm going to rewrite with what I call the plug-in. So the r is 8, here it is. The a is 6, there's the 6, plus the 10. Now I can add these together. All right, so I get a 14 times that 8 plus the 10. And off on the side, I'm going to run this little multiplication. Okay, so that's 32, 8, 9, 10, 11. So that's 112 plus the 10. And we can go across now, right? So 122. So 122 pieces of fruit. Now over here, this side, we can do something similar, right? So different expression should have the same results. 8 oranges, right? So times 8, there it is. Plus this 8, the first 8, times the amount of apples, which is 6. Again, this is the plug-in. There's that plus 10. So here we have that 64 plus the 48. See the 48 plus the 10. And so on the side here, I'll just add them all up, and hopefully we should have this answer down here, right? So there's a 12. 6 plus 4 is 10. And 11 and 12. 122. Look at that. 122. So 122 total pieces of fruit. There it is. So 122 total pieces of fruit. See? So everything's equivalent to one another. I just proved that both equations are totally equivalent. Okay? So there you go. And let's cruise on down. What else we have going on here? I don't think I wanted to do anything there. Here we go. How about a couple of these? These are fun. So page 205. We'll hang out here for a little while. If you want to stay, awesome. If you're feeling pretty good, then hey, by all means, go do something else, I guess. I don't know. Let's see. So let's distribute. There we go. So I had that 9 plus. And so it was 7 times the 3x plus, right? There's that plus. We'll distribute that 7. 7 times the 4. See? And now we'll just start multiplying. So whatever we can combine here, there's a 21x, right? 7 times 3x, 21x plus good old 28. Okay, well, this guy and this guy I can combine. So I'm going to put that 21x right there. That should be an x. I don't know what that is. There you go. And I'll take my 28 and I'll add my 9. Right? Nice and neat. And 37. Okay, so there you have it. Just like that. Okay, so let's see. Oh, I guess I'll might as well do this one too. So let's see. So here's a 2x plus, right? 2x plus. Let's distribute that 3. So 3 times the 4x minus this time. There's a minus there. Careful. Distribute the 3 to the 5. So 3 times 5. Okay. So let's multiply everything we need to multiply. So that's a 12x there. And there's a 15 there. And we're looking pretty good. So let's combine like terms. Okay. So these guys here are like terms because they share the same variable raised to the same power. That's what makes them like terms. So 2 plus 14 or 2x plus 14x gives me 14x's minus the 15. And we are done. Okay. Now this guy here, this guy can get complicated. So first thing, choose all that apply. Well, I guess I'm just going to take this guy and just have some fun with him. And looks like there's a fraction involved. Okay, let's see. So So let's distribute. So there's that 8x. All right, maybe I won't do all of this, but we'll do a little bit of it. All right. There's that 1/3. Sorry, that should be a third times the 6x, right? We distributed minus, right? See, there's the minus. Now we're going to distribute that 1/3 again to the 12, right? Distributive property. So 8x comes down. I'm not doing anything with that yet. And now this guy here, I'm going to take 1/3 of 6, right? That goes in within once. 3 goes in there twice. So that becomes 2x minus, well, what's 1/3 of 12, right? That goes in. 3 goes into 3 once. 3 goes into 12 4 times. So I get a 4. Okay, now I can combine these guys, right? So that gives me 14x minus 4. Okay, so now I can just take a look. Let's see what happens here. If anything matches up with that. Let's see. Okay, so I see I made a little bit of a mistake here. I'm going to put that right there. That was 2. So 1 times 2 is 2x. Gee whiz. So that changed everything. So I'm just going to, that's 8x plus 2x is 10x. Made a little mistake there. Sorry. But now we can move forward. So let's see here. So let's go over here. So does this guy work? I'm not sure. So 8x plus 2x minus 12. No, I've got a minus 4 over here. He's not working. No, no, no. So he's out. Let's see. 8x plus 1/2 x. No, I got a 2x over there. So he's out. No. Let's see. 8x plus 2x minus 4. Oop, he matches with this guy. So yes, I like him. 10x minus 4. Oop, that's this guy over here. So he's good. Let's see. How about the 8x plus 2? Well, if I distribute this guy, right, I'm going to wind up with 8x plus 2x and then distribute minus a 4. There it is. Yeah, so he works also. So that guy works. Now this guy, if I distribute 8x plus 3x minus 12, that's a 3x minus 12. No, that's not working. So no dice there. Okay, so we're doing pretty well. This guy here, well, this one, let's see. Are these guys equivalent to one another? Well, 2 times x is really x plus x, right? This guy's x times x. So that's a big old no. They're not equivalent. If I distribute this guy, I get a 10x there. If I distribute this guy to this guy, I get a plus 15x. And so they do work. Yeah, so that's a big old yes. Okay, and that's how that works. Right, those go pretty quick. And then there's one last problem I wanted to get to. It's a stairwell problem. This guy, this is kind of fun. It looks like a stairs, I guess, but it's really a perimeter problem. Finding a perimeter means you add up all the sides. Well, look at my sides here. I only have a whole bunch of, let's see, x's, y's, and w's, but I have to add them all up, right? So what I like to do is just start with the x's, and I'll just circle all of them. I'm going to find them all. X's, x's, there's an x, all the x's. So the perimeter, always use P for the perimeter, is going to equal, actually typically I use a capital P, right? Is going to equal, let me move it up a little bit. I might need the space. Let's see, put it up here. Is going to equal all these x's, right? 1, 2, 3, 4, 5, 6 x's. And everything's addition with perimeter, right? We're adding everything. The y's, how about I put a box around the y's? These are all the same size, these y's. 1, 2, 3, 4, 5. 5y. And then don't forget the w that's right there. I'll put a plus that w. He's the only one, so that he stays just like that. Okay, so write 3 expressions. They want 3 expressions that each represent the same perimeter. Well, I can split this up. Maybe I can do a 6x, excuse me, a 3x plus a 3x plus, right? Because that gives me the 6x. How about a 4y plus another y, because that'll give me 5y, plus the w. You can do that. I mean, you can do anything, really. There's just so many. How about I just do, how about I just separate all the x's? X plus the x plus the x plus the x. 1, 2, 3, 4, 5, 6 x's. There they are. How about 5 y's? 1, 2, 3, 4, 5. And then tag on that w. That works too. Those are all equivalent expressions. Okay, but it looks like a lot of fun too at the same time. So, well, that was it, right? So hope you have fun with that. And that's the deal, right? Distributed property, lots of fun. Okay, folks, take care. So long. Bye bye.